Um, Welcome, everyone. Step right in and,
Yeah, get comfortable.
right, get comfortable and let's get focused. It is Friday, March 6th, 2026.
A very interesting time to be looking at the markets.
It really is. Because if you've been paying any attention to the world outside your window recently, you know that things are shifting.
Rapidly.
Exactly. The tectonic plates of the global economy are moving incredibly fast, right before our eyes. And, well, we are just thrilled to have you here with us to make sense of it all.
Absolutely.
Whether you are prepping for a massive supply chain meeting at work, or looking at your tech portfolio wondering where the market is actually heading, or,
Or you're just insanely curious about why your groceries cost exactly what they do right now.
yes, that is a big one, you are in the right place.
It's fantastic to be here. And I have to say, the visual space we're operating in today, it perfectly captures the exact mood of the material we are about to unpack.
Quite a backdrop, isn't it?
It is. We have this sweeping, neon lit view of the Nevada desert at dusk in the background. But if you look closely at the horizon, you can see these cascading, illuminated data streams of global supply chain routes overlaid right on top of the physical landscape.
I love that.
It's a striking representation of how the digital world and the physical, heavy industrial world are currently colliding out there in the sand.
That collision is exactly what our mission is about today. We have an incredibly dense, fascinating stack of source material to get through.
Very dense.
Today we're analyzing a highly detailed, intense script that was originally designed for a 10-minute video presentation. This text is entirely focused on an impending global logistics revolution.
But our mission today goes a bit deeper than that.
Right. We want to look past the flashy headlines. We want to look past the Mars rockets and the humanoid robots doing backflips on social media to uncover the real silent economic earthquake that is happening right now in that Nevada desert.
The quiet revolution.
Exactly. So, okay, let's unpack this, because there is a massive irony sitting right at the center of the analysis today.
There is a profound irony, and it's something that feels almost too obvious once it is pointed out, but it remains completely invisible to the general public until that exact moment.
Which is?
The analysis argues that while the entire internet and the mainstream news cycle are completely distracted by Elon Musk's Optimus robot, or the latest updates on getting a human colony to Mars.
The flashy stuff.
Right, the flashy stuff. But the real monster, and that specific word, monster, is used deliberately in the source to describe its economic impact, is the Tesla Semi.
The heavy-duty commercial truck.
Yes, it is not as visually stunning as a rocket ship breaking the atmosphere, but the argument being made is that it is infinitely more disruptive to the daily mechanics of human civilization.
I think we really need to start by framing the stakes here.
Yeah,
It is so easy to hear the words commercial trucking and immediately just tune out.
most people do.
Right? They think, well, I don't drive an 18-wheeler. I don't own a logistics company. I don't manage a warehouse. Why should I care about a commercial vehicle?
It's a fair question for the average consumer.
But the reality, as outlined in our material, is that logistics is a hidden tax on absolutely everything you buy.
Everything.
The smartphone in your pocket, the cotton t-shirt you're wearing right now, the fresh produce sitting on the shelves at your local grocery store, the drywall in your house. The prices of all those items are heavily dictated by a hidden underlying system.
And right now, today, that system is a 100-year-old, highly polluting, incredibly inefficient network of diesel trucks.
Exactly.
That phrase, hidden tax, is the absolute perfect lens for this entire
It
discussion.
makes it real for you.
Yeah, when you realize that every single time you buy a t-shirt, a significant percentage of that price tag is just paying for the diesel fuel it took to get that shirt from a port in Los Angeles to a sorting facility in the Midwest to a retail store in your neighborhood. Suddenly, commercial trucking becomes the most important economic topic in the world.
You're paying for the inefficiencies of that diesel engine with every swipe of your credit card.
Precisely.
So here is our roadmap for this deep dive. We are going to explore the staggering economics of this new Nevada factory and why it fundamentally breaks traditional manufacturing models.
Which is a fascinating shift in itself.
Then we are going to look at the absolute terror that 247 full self-driving is going to inflict on legacy competitors, the real-world implications of a machine that simply doesn't sleep.
The sleepless giant.
Right. After that, we'll examine the moat, or why legacy automakers can't just slap a battery in their old trucks and compete. And finally, we're going to look at how this single vehicle could fundamentally restructure global inflation using a historical parallel that I found absolutely fascinating.
It is a massive scope, but the mechanic of it are laid out with brutal clarity. We are watching the transition from an era of combustion and biological human limitation into an era of relentless automated efficiency.
And the tipping point isn't a decade away, it's happening right now.
Right now.
Let's jump right into part one of our outline, the end of the diesel era and the 50,000 tipping point. Up until very recently, the Tesla Semi was essentially in an extended pilot phase,
Yeah, you might have seen a few of them out on the highway in California.
with a Pepsi or Frito-Lay logo on the side, right?
Exactly. They were doing small-scale tests, running daily regional deliveries, essentially just acting as data-gathering nodes.
But that quiet era is over. The source material notes that the new Nevada factory has been engineered with an explosive mass production target of 50,000 units annually. Now, I have to play devil's advocate for a second.
Go for it.
To the average person, 50,000 vehicles sounds like nothing. Toyota makes 10 million passenger cars a year. Why is 50,000 such a seismic number in this context?
It's a great question because context is everything here.
Yeah.
You simply cannot compare the passenger car market to the heavy-duty truck market.
They're different worlds.
Entirely. We are talking about Class 8 trucks. These are the massive 80,000-pound tractor trailers that require specialized heavy-duty axles, immense structural frames, and powertrains capable of hauling literal tons of cargo up steep mountain grades.
So the overall pool of these vehicles is much smaller.
Exactly. The entire Class 8 market in North America is only about 250,000 to 300,000 trucks in a very good year.
Wow. Okay, so the denominator is much smaller.
Yes, the total addressable market in a given year is a fraction of the passenger car market. In that specific, highly constrained environment, producing 50,000 units of a single highly advanced model in 1 year is not just a successful product launch.
It's a takeover.
It is an absolute bombardment of the industry. It's a volume that completely shatters traditional commercial vehicle manufacturing norms.
Yeah.
Traditional truck manufacturers, the legacy brands that have dominated for decades, might celebrate selling 10 or 15,000 units of a specific heavy-duty model over several years.
So dropping 50,000 into the market in a single year.
Dropping 50,000 units of a paradigm-shifting electric truck into the market in a single 12-month cycle changes the gravitational pull of the entire logistics sector. It forces every competitor to instantly react or be entirely marginalized.
That puts it into a terrifying perspective for the legacy brands. A fifth of the entire market potentially swallowed by one model in its first major production run.
It's unprecedented.
But to understand why those 50,000 trucks are going to be snapped up the second they roll off the line, we have to talk about the mindset of the buyer. I imagine a commercial truck is a totally different psychological purchase than a passenger car.
Oh, absolutely.
It's just a math equation, right?
Yeah.
When you or I go to buy a car, we care about the color, the way the leather on the steering wheel feels, the brand prestige.
How the headlights look when it's parked in the driveway.
Exactly. It is deeply emotional. But a commercial fleet manager doesn't care if the truck is shaped like a brick or a spaceship, as long as the math works.
That is precisely it. A commercial truck is a tool meant strictly to print money for a business. There is zero emotion involved in the boardroom of a logistics company. It all comes down to one single overriding metric: total cost of ownership.
TCO.
TCO. Every purchasing decision is run through a spreadsheet that calculates exactly how much this vehicle will cost to buy, fuel, and maintain over its lifespan, divided by the revenue it can generate.
Let's dig into that spreadsheet because this is where the material really starts to dismantle the traditional diesel model.
Yeah.
When you look under the hood of a traditional diesel truck, you aren't just looking at an engine.
No, you're looking at a maintenance nightmare waiting to happen.
Let's talk about why.
What's fascinating here is the gritty realities of what maintaining a modern diesel engine actually entails. It is not just about changing the oil every few thousand miles, although a massive diesel engine takes gallons of specialized engine oil, which is expensive. It is about the incredibly complex exhaust systems. Modern environmental regulations have forced diesel manufacturers to bolt on highly sensitive, breakable components just to keep the emissions at legal levels. We are talking about DPFs, diesel particulate filters, and DEF, diesel exhaust fluid systems.
And for anyone who hasn't worked in fleet maintenance, those acronyms are the bane of a mechanic's existence. A diesel particulate filter, physically traps the soot from the exhaust, and it has to get incredibly hot to burn that soot off.
Exactly. And if the truck is just idling in traffic,
It doesn't get hot enough, the filter clogs, the sensor goes off, and the truck's computer throws it into limp mode.
limp mode is the worst fear of a driver. And the DEF system is just as bad. It injects urea into the exhaust stream to break down nitrogen oxides. It requires its own tank, its own pumps, its own heaters to keep the fluid from freezing in the winter, and a network of highly sensitive sensors.
So many points of failure.
If one of those nitrogen oxide sensors fails, and they fail constantly because they live inside a vibrating superheated exhaust pipe, the truck stops. It legally cannot run. So you have this incredibly fragile ecosystem of parts bolted onto a violently vibrating internal combustion engine.
And the Semi has literally none of that.
None of it. It was an electric drivetrain. There is no massive block of iron vibrating violently. There is no engine oil to change. There is no multi-speed mechanical transmission fluid to flush. There is no complex multi-stage exhaust system to maintain or replace.
No DPFs to clog.
No DEF pumps to freeze. You have a battery, inverters, and electric motors. The mechanical simplicity is staggering.
Which leads us directly to the most critical concept in logistics. Downtime. If I'm looking at that TCO spreadsheet, the maintenance line isn't just the cost of the new sensor or the mechanic's hourly rate. The real financial bleed is the downtime.
Exactly.
If that truck is sitting in the repair bay waiting for a back-ordered DEF pump, that truck is not moving freight.
And if it is not moving freight, it is actively burning money. You still have to pay the driver who is sitting in the break room. You are missing your delivery windows. Your clients, the massive retail chains, are angry and potentially fining you for late arrivals. You are losing top-line revenue by the hour.
It cascades.
It does. Because the Semi has a tiny fraction of the moving parts of a diesel truck, it effectively deletes this downtime from the equation. The structural lack of complex, breakable internal combustion components translates to a vehicle that simply stays on the road. The utilization rate skyrockets.
So it doesn't break down, which saves a fortune. But the savings just keep compounding when you look at the daily operations. The analysis directly compares the fuel costs, and this is where the physics of electric motors just embarrass the internal combustion engine.
The physics are undeniable.
An electric motor is something like 90% efficient at turning stored energy into forward motion, whereas a diesel engine wastes a massive amount of its energy just generating heat and noise. Because of that inherent efficiency, the cost to fuel the Semi with electricity is slashed by more than half compared to the cost of diesel fuel to go the exact same distance.
So let's summarize the operational side of the TCO before we even get to the purchase price. You have a truck that practically eliminates mechanical downtime, drastically reduces maintenance costs because it lacks the fragile exhaust and fluid systems, and costs less than half as much to fuel per mile.
It's a compelling argument.
You can see why the math starts to heavily favor the electric model. It is a leaner, more resilient tool.
But wait, I have to stop you there and push back again. Because everything we just talked about, cheaper maintenance, cheaper fuel, that's the classic EV argument. We hear that all the time with passenger cars.
We do.
People say, sure, the EV is cheaper to run over 5 years, but it costs more upfront. Batteries are incredibly heavy, they require complex mineral supply chains, and they are notoriously expensive to manufacture. It is generally accepted that an electric Class 8 truck, which needs an absolutely massive battery pack, is going to have a significantly higher initial purchase price than a diesel truck.
That is the assumption.
So the fleet manager has to take a massive upfront capital hit and wait years to earn it back in fuel savings. Doesn't that slow down adoption?
That is the conventional wisdom, yes. But here is where the material drops what is arguably the most shocking financial claim of the entire analysis. We're not just looking at operational savings over a 5-year horizon.
Okay, what are we looking at?
The data indicates that we are rapidly approaching a miracle crossover point. This is the moment where the upfront purchase price of the Tesla Semi actually undercuts the upfront purchase price of a traditional diesel truck.
Undercuts it, meaning the electric truck with a massive, highly advanced battery pack is cheaper to buy on day one than the diesel.
Yes.
How is that mechanically and economically possible?
It is a combination of two massive converging forces. First, we have to look at the manufacturing mechanics of the Gigafactory itself and the concept of Wright's law.
Right.
When you are targeting a production run of 50,000 units annually, you achieve a level of economies of scale that no other electric truck manufacturer has even approached. You are buying raw materials in unprecedented bulk. You are automating the battery cell production lines to run continuously. You are casting massive parts of the chassis in single pieces rather than welding hundreds of smaller parts together.
So the efficiency goes through the roof.
Mass production ruthlessly and systematically lowers the per unit cost.
Okay, the scale drives the base cost down.
Yeah.
But surely not below a diesel engine that has had 100 years to optimize its supply chain.
That is where the second force comes in, government policy and green energy subsidies. The analysis explicitly factors in the impact of sweeping legislation, specifically citing the Inflation Reduction Act, or the IRA, in the United States.
Let's be clear. We aren't taking a political stance on whether the IRA is good or bad policy. We are just looking at the raw math of how it affects the spreadsheet of our hypothetical fleet manager.
Precisely. Impartially speaking, the IRA was designed with specific provisions to incentivize the decarbonization of commercial transport. It provides massive financial credits, up to $40,000 per vehicle in some cases, for purchasing heavy-duty commercial clean energy vehicles.
That is a massive chunk of change.
So when you combine the rapidly lowering internal cost of battery production driven by the sheer scale of 50,000 units, and you layer on tens of thousands of dollars in government subsidies designed to artificially lower the barrier to entry, the initial purchase price plummets.
But let me challenge that. Subsidies are, by nature, political and temporary. What happens if a new administration comes in and wipes out the IRA? Doesn't the miracle crossover vanish, leaving the fleet manager holding the bag on a much more expensive truck?
That is a very valid concern in the short term. However, the analysis suggests that the cost curve trajectory outpaces the reliance on subsidies. Yes, the subsidies accelerate the crossover point right now, but because of the scale the Nevada factory is achieving, the underlying cost to produce the truck is dropping so fast that within a few years, it won't need the artificial support of the IRA to undercut diesel.
So it's just a catalyst.
The subsidies act as a bridge to get the factory to maximum volume. Once it is at maximum volume, the pure physics and economics of electric manufacturing take over.
So let's put ourselves back in the shoes of that logistics CEO. You are sitting at your desk, looking at a proposal to replace 20 aging trucks in your fleet. On the left side of your desk, you have the quote for 20 new diesel trucks. On the right side, you have the quote for 20 Tesla semis.
And you compare the numbers.
Thanks to the scale and the current subsidies, the semi requires less upfront capital. It costs half as much to fuel every single day. Has no engine oil, no transmission fluid, no DPF filters to clog, no DEF sensors to fail, and practically zero mechanical downtime.
Correct.
If you choose to sign the contract for the diesel trucks knowing all of this, the analysis implies that your decision borders on corporate malpractice.
It is a strong term, but financially accurate. If a CEO has a fiduciary duty to their shareholders to maximize the profitability and efficiency of the company, willingly choosing a tool that has a higher upfront cost, a significantly higher daily operating cost, and lower reliability is a guaranteed multi-million-dollar loss over the lifespan of that fleet.
You can't justify it to the board.
You would be actively harming your company's bottom line out of sheer stubbornness or an irrational attachment to legacy technology.
It's an undeniable math equation. The demand isn't a question mark. The demand is infinite because the math demands it. The only bottleneck was the supply.
Exactly.
Once that Nevada factory opens the floodgates and hits that 50,000 unit run rate, the adoption curve isn't going to look like a gradual bell curve. It's going to look like a vertical line.
A vertical line that completely shatters the 100-year monopoly of the internal combustion engine in heavy transport. It is incredible to think about the sheer mass of resources, the drilling, the refining, the pipelines, the specialized mechanic schools, the aftermarket parts industry that currently go into maintaining that diesel infrastructure, and how quickly it is about to be rendered economically obsolete.
It is a massive structural shift. But as overwhelming as the cost savings of the physical truck are, the material makes a pivot here that is truly mind-bending.
This is my favorite part of the analysis.
It argues that the TCO of the vehicle itself is only part of the story. The real disruption, the thing that completely breaks the established laws of physics in the logistics industry, isn't what's under the hood, it's what happens in the cab. That brings us to part 2. The sleepless giant and how 247 full self-driving changes absolutely everything.
This is where we transition from a conversation about building a more efficient truck to a conversation about inventing a completely new paradigm of global transportation. To fully grasp the magnitude of the solution, we first have to rigorously define the massive vulnerability in the current supply chain.
Let's set the scene to make this real. Imagine you are driving cross-country. It is 3 a.m., you are on Interstate 80 somewhere in Nebraska, and it is pouring rain. You see this massive wall of 18-wheelers hurtling down the highway, surrounded by a cloud of mist.
It's an intimidating sight.
Each one of those trucks is a 40-ton missile carrying millions of dollars worth of critical goods, medical supplies, electronics, food. And the entire safety and success of that journey relies on one incredibly fragile biological element sitting behind the steering wheel: the human driver.
The material identifies the human operator as the ultimate, insurmountable bottleneck in the U.S. supply chain. We have engineered incredible machines, but we have tethered them to the limits of human biology.
It's a harsh reality.
And the reality of commercial trucking as a profession is brutal. We are talking about people sleeping in tiny, vibrating bunks behind the driver's seat. We are talking about eating bad food at truck stops, dealing with the constant stress of traffic and weather, and being away from family and home for weeks at a time. The physical and mental toll on these drivers is enormous.
I always think about driving past those massive rest stops at night, seeing hundreds of trucks idling in the dark, packed together like sardines. It is a grueling lifestyle. And because it is so demanding, the industry faces massive turnover.
Huge turnover.
The analysis notes that it almost doesn't matter how high logistics companies raise the wages. Fewer and fewer young people want to enter this profession. It is a job that fundamentally degrades your health.
And beyond the difficulty of hiring and retaining drivers, there is a hard, inflexible regulatory limit placed on the human body.
The safety rules.
Exactly. For obvious safety reasons, human biology must be regulated. In the United States, this is governed by the Hours of Service, or HOS, regulations. A commercial driver legally cannot drive more than 11 hours in a 14-hour on-duty window. And after that, they are strictly mandated to take a 10-hour off-duty rest period.
And this isn't the honor system anymore, is it?
Not at all. Trucks are equipped with electronic logging devices, or ELDs, that track every single minute the wheels are turning. If a driver goes over their hours, they are heavily fined and the truck is forced off the road.
So, what does that biological limitation actually mean for the macro supply chain? It means that you have perfectly good, incredibly expensive, $250,000 assets sitting completely idle on the side of the road or in a noisy truck stop for roughly half of their existence.
Half their life just parked.
The movement of goods across the country is literally frozen for 10 to 12 hours a day. Not because the engine needs brake, not because the tires need to cool down, simply because the primate operating the machine requires unconsciousness to repair its cells.
It is a massive systemic inefficiency built right into the core foundation of global trade. We accept it because we have never had an alternative. Half the time, the capital asset isn't even being utilized.
But here is where the paradigm completely flips.
The analysis introduces the semi-secret weapon. Every single one of these heavy-duty trucks rolling out of the Nevada factory comes equipped with full self-driving, or FSD, hardware, the cameras, the inference computers installed straight out of the factory. The material refers to them not as trucks, but as wheeled AI.
Here's where it gets really interesting, because I could hear the skepticism through the speakers. A passenger car driving itself around a quiet suburban neighborhood is one thing. But how does a neural net, trained mostly on data from a Tesla Model 3 or Model Y, safely handle an 80,000-pound articulated vehicle with entirely different physics?
It's a valid concern.
A truck can jackknife. A truck takes the length of a football field to stop. It suffers from brake fade. It catches wind shear differently. How does the AI bridge that massive physical gap?
It is a monumental engineering challenge. But the core architecture of the neural net is designed to understand physics, not just memorize routes. The cameras feed visual data into the system, and the AI interprets the 3D vector space around the vehicle.
Right.
The difference is the software's control algorithms. The AI knows the weight of the trailer. It can calculate it based on the torque required to accelerate. It knows the braking limits. Because the AI is looking hundreds of yards down the highway with multiple cameras, it actually predicts traffic patterns and braking events far earlier than a human driver ever could.
That makes sense. A human reacts to the brake lights of the car immediately in front of them.
Exactly. But the AI reacts to the cascading flow of traffic a quarter mile ahead, allowing it to begin regenerating power and slowing the massive weight down smoothly without ever locking up the brakes or risking a jackknife.
It is a machine that perfectly understands its own physical limitations in real time. And the implications of deploying this wheeled robot in the logistics space are truly staggering.
They change the entire math equation of the industry.
These machines do not eat. They do not need bathroom breaks. They do not get tired. Their eyes do not droop at 3 a.m. They do not check their phones or get distracted by a billboard. And most importantly, they do not have hours of service limitations.
No ELDs tracking their sleep.
They are entirely immune to the biological constraints that have dictated the pace of human trade since the invention of the wheel.
When you pair this relentless artificial intelligence with the physical infrastructure of the ultra-fast megachargers that are being deployed, you get a commercial vehicle that can run 24 hours a day, 365 days a year.
Wait, let's talk about the megachargers quickly, because that is another physics problem. If I plug an EV into my wall at home, it takes hours to charge. Even at a supercharger, it takes 20 or 30 minutes. How do you charge a battery the size of a small house fast enough to keep this 240-7 cycle going without melting the charging cables?
You literally have to liquid cool the cables. A standard fast charger might deliver 150 or 250 kilowatts of power. The megachargers are designed to deliver megawatts over 1,000,000 watts of power continuously.
1,000,000 watts. That's insane.
Pushing that much electricity generates immense heat. So the charging cables themselves have liquid coolant running through them to prevent the wires from melting under the thermal load. This allows the truck to pull in, ingest a massive amount of electricity in roughly the time it takes to unload a trailer or swap a driver and get right back on the highway.
So no hotels, no mandated 10-hour rest periods at truck stops.
None of that. It is a system of relentless, continuous motion.
Let's synthesize the operational impact of that relentless movement. The source provides a vivid prime example that really crystallizes the difference between the human era and the AI era.
The LA to NY miracle.
Yes. Imagine a shipping container full of electronics from Asia lands at the port of Los Angeles. Under the current biological system, getting that container across the country to a distribution center in New York takes roughly 4 to 5 days. That timeline accounts for the legal driving limits, the mandated sleep periods, the food breaks, the traffic jams, and potentially driver changeovers.
4 to 5 days. That is the deeply established speed of commerce in the United States. Entire supply chains, warehouse schedules, and retail expectations are built around that specific rhythm.
Right. Now, replace that human-driven diesel truck with a full self-driving Tesla semi running on a megacharger network. According to the analysis, that exact same journey for the port of Los Angeles to the warehouse in New York takes exactly 2 days, 48 hours.
From 5 days down to 2. It cuts the cross-country transit time by more than half.
And we really need to unpack the macro implication of that phrase, speed and turnover, because it is very easy to look at autonomous trucking and cynically say, oh, the corporations are just trying to save money by firing the human drivers.
That's the surface level read.
But the analysis insists it is so much bigger and more profound than just labor arbitrage. It is about fundamentally doubling or tripling the efficiency of the entire national network. Think about the concept of the velocity of capital.
This is where the economics get truly fascinating. Think about what inventory actually is. When a company has a shipping container full of laptops slowly making its way across Nebraska for 5 days, that is millions of dollars of cash that is completely frozen.
It's trapped in a box on wheels.
Exactly. It cannot be sold. It cannot be invested. It is just sitting in a dark box. If a truck can do 2 cross-country trips in the time it used to take to do 1, the physical infrastructure of the economy effectively doubles its output without the government having to pour a single new mile of concrete highway.
Think about what that means for your expectations as a consumer. When freight moves twice as fast across the country, your expectations and the financial structures of the companies you buy from fundamentally shift.
The inventory requirements drop entirely.
Yes. Companies don't need to hold massive, expensive stockpiles of goods in regional warehouses if they know with absolute certainty they can get a restock from across the continent in 48 hours instead of a week. They can dramatically reduce their warehouse footprint.
That frees up billions of dollars in capital that was just sitting on shelves gathering dust. It makes the entire economy leaner, faster, and infinitely more responsive to demand. Just-in-time delivery on absolute steroids.
It completely rewrites how businesses manage their cash flow and their physical footprint. But let's look at the dark side of this equation for the legacy transport company.
It is a dark side.
The analysis outlines a brutal, unforgiving reality. Freight owners, the massive retail companies actually paying the logistics firms to move their goods, do not care about the nostalgia of a diesel truck. They do not care about legacy brands. They care about 2 things, speed and cost.
Period.
If a new tech-forward logistics company using FSD semis can guarantee delivery from LA to NY in 2 days for less money, while the legacy diesel company takes 5 days and charges more to cover their fuel and driver costs, who's going to get the contract?
It's not even a negotiation. The freight owners will aggressively and ruthlessly route all their contracts to the fleets using semis because they are universally faster and universally cheaper. It is a complete no-brainer for the customer.
And that is why the material describes this impending shift as an extinction-level event for slow, diesel-dependent fleets.
Extinction level, yes.
It is not just a scenario where they might lose a few percentage points of market share. It is a scenario where they become structurally and fundamentally uncompetitive. They will be trying to sell a 5-day, high-cost, high-emission service in a market that has instantaneously acclimated to a 2-day, low-cost, zero-emission standard.
You cannot survive that kind of paradigm shift through better marketing. It is exactly like trying to sell dial-up internet subscriptions in an era where fiber optics are available for half the price.
Yeah.
The market simply moves on and it leaves the legacy infrastructure stranded.
It really is a terrifying prospect for
Yeah.
anyone holding the bag on a massive fleet of diesel trucks or anyone who just signed a 5-year lease on a traditional maintenance facility. They are about to watch the foundational premises of their entire business model evaporate in real time.
The market waits for no one.
But that raises a massive, glaring question. What does this all mean for the other heavy truck manufacturers? It is not like Volvo, Daimler, Freightliner, and Scania are just sitting around in boardrooms doing nothing right. They read the news. They see the writing on the wall. They're building their own electric trucks. Are they putting up a fight?
This takes us right into part 3, the moat. Why legacy automakers can't catch up.
So what are they doing?
The analysis addresses this counterargument directly and sharply defines the massive gap between what legacy automakers are doing and what Tesla's doing. Yes, legacy brands are absolutely putting out electric trucks. You can go to a trade show today and see electric Volvos and electric Freightliners.
Yeah.
But the material argues that this is largely an illusion of competition because those legacy electric trucks are hitting a massive, unforgiving brick wall when it comes to range, engineering, and infrastructure.
Let's look at the specific performance specs highlighted in the text to ground this. The source notes that the Tesla Semi is engineered to achieve 800 kilometers of range, that is roughly 500 miles, while fully loaded to the legal maximum of 80,000 pounds of combined truck and cargo weight.
Which is a massive feat of physics.
Moving 40 tons of mass 500 miles at highway speeds on a single charge requires a level of aerodynamic efficiency, motor efficiency, and battery energy density that the legacy automakers are currently struggling to even approach, let alone mass produce at a profit.
To understand why the legacy brands are struggling to match those specs, we have to look at the engineering philosophy. Legacy automakers are suffering from a deeply entrenched legacy mindset. They are treating the electric vehicle transition simply as a powertrain swap.
Okay, what does a powertrain swap mean in this context, and why is it a flawed approach?
Think about how a traditional diesel Class 8 truck is built. The entire steel frame, the suspension, the aerodynamics, the cab placement, it is all meticulously designed around housing a massive, heavy, vibrating block of iron, the internal combustion engine right in the front.
And a massive radiator to cool it.
Exactly. There needs to be a massive grill to push air through a giant radiator. When legacy automakers try to build an EV, their first instinct is to take that existing, perfectly good chassis, pull the diesel engine out, and try to cram thousands of pounds of battery packs wherever they can find room.
Like strapped to the side of the frame rails.
Yes, strapped to the side of the frame rails or shoved under the cab.
So they're basically saying, hey, we made an electric truck. It looks exactly like our old truck. It just whines instead of rumbles. Good luck charging it.
That's pretty much it.
Yeah.
And the physics of that approach are terrible. The weight distribution is entirely wrong, which affects handling and tire wear. The aerodynamics are still optimized for cooling a diesel engine that isn't there, creating unnecessary drag, which murders battery range.
It's highly inefficient.
Tesla, on the other hand, built the Semi on what we call a skateboard chassis. They started with a blank sheet of paper. The heavy battery pack is laid flat along the very bottom of the vehicle between the axles.
Lowering the center of gravity.
Exactly. It gives the truck an incredibly low center of gravity, making it almost impossible to roll over. The motors are integrated directly into the rear axles. The cab is pushed forward and shaped like a bullet because there is no massive engine block to sit behind. Every millimeter is optimized for aerodynamic flow and electrical efficiency.
It's the difference between trying to turn a horse-drawn carriage into an automobile by strapping an engine to the axle versus designing a car from scratch.
That's a great analogy.
But the engineering of the truck itself is only the first layer of the defense.
Yeah.
The analysis explains that Tesla's true insurmountable moat, the reason legacy automakers can't just reverse engineer the truck, copy the aerodynamic shape, and compete, is because Tesla is not just selling a truck.
If we connect this to the bigger picture, they are selling a turnkey ecosystem. It is a concept of absolute airtight lock-in.
Let's break down that turnkey ecosystem, because this is where the business strategy elevates from manufacturing to monopoly building. It is not just the physical vehicle, it is the proprietary megacharger network.
This is crucial. Legacy automakers are building electric trucks, but they are relying on third parties or hoping for government grants to build the heavy-duty charging stations. They are selling a product that has no fuel infrastructure,
Which is a huge risk for the buyer.
Tesla is not waiting for the government. They are vertically integrating. They are building a dedicated network of ultra-fast megachargers along the major freight corridors themselves.
So when a logistics company buys a semi, they aren't left holding a highly advanced piece of hardware and wondering how to fuel it. The fueling infrastructure is part of the package. It's guaranteed.
It is a massive de-risking for the fleet manager. And the second, perhaps even more critical piece of the ecosystem moat is the FSD AI software. Legacy automakers might, given enough years and billions in R&D, eventually build a decent aerodynamic electric truck with a skateboard chassis. But they absolutely do not have the AI software ecosystem trained on billions of miles of real-world driving data.
Right, because Tesla has been treating every single passenger car they've sold for the last decade as a data gathering probe.
Every single one.
They have been collecting visual corner case data from millions of Model 3s and Model Ys in snowstorms, in chaotic city traffic, in rural dirt roads, training their massive neural supercomputers to understand every possible edge case on planet Earth. And now they're porting that massively advanced, road-tested, billion-mile brain directly into the semi.
The legacy companies are fundamentally playing the wrong game. They are spending millions trying to build a better hammer, while Tesla is walking in and selling the customer a fully automated, AI-driven factory.
It's incredible.
The material makes it exceedingly clear. By combining the proprietary, reliable charging network with the advanced, constantly updating FSD software, Tesla effectively locks the logistics companies into their ecosystem.
It's the Apple ecosystem model, but applied to heavy industrial freight. Once you buy an iPhone and all your photos are on iCloud and you have an Apple Watch, it is incredibly painful to switch to an Android phone. Even if the Android phone has a slightly better camera, the switching costs are too high.
Exactly. Once a fleet manager transitions their routing software, their dispatcher training, their maintenance schedules, and their financial models to the Tesla ecosystem, where the trucks charge themselves at Tesla stations and drive themselves using Tesla software, the switching costs to go back to a legacy electric truck that lacks the integrated charging network and the autonomous capabilities are simply financially unviable.
You're locked in.
It is a protective moat built on billions of lines of code and proprietary electro infrastructure, not just stamped metal and fiberglass.
It is a total paradigm shift in how commercial vehicles are bought, fueled, and operated. And this perfectly sets up the massive historical and macroeconomic implications of what we are witnessing. Which brings us to part 4, the J.P. Morgan parallel and the death of inflation.
This is where we look at the big picture.
I want to shift the visual backdrop in our minds here dramatically. Imagine peeling away the neon data streams of the Nevada desert and replacing it with a sepia-toned 19th century map of the American continent. Imagine thick black lines of railroads slowly pushing westward, connecting the East Coast to the frontier, violently industrializing a wild continent.
It's a very evocative image.
The analysis introduces a brilliant historical analogy here to explain what is happening today.
It is a very powerful, very apt comparison. The material looks back to the era of J.P. Morgan in the late 19th and early 20th centuries. During the Gilded Age, Morgan looked at the landscape of the American railroad industry, and he didn't see progress. He saw absolute chaotic ruin.
Let's give some context to that chaos. In the 1880s and 1890s, the railroad industry was a mess. You had hundreds of small, inefficient, wildly competitive railroad companies. They were overbuilding tracks right next to each other, engaging in ruinous price wars, and constantly going bankrupt.
And no standardization?
None. They even used different track gauges, meaning the width between the rails was different. So a train from one company literally couldn't drive on the tracks of another company. It was incredibly slow, fragmented, and expensive for the businesses trying to ship goods.
It was a massive drag on the emerging American economy. J.P. Morgan, operating out of his banking headquarters and famously holding meetings on his yacht, the Corsair, stepped into this chaos. He used his immense financial leverage to consolidate these failing, fragmented companies.
He brought order to the chaos.
He forced them into unified trusts. He standardized the track gauges, synchronized the schedules, eliminated the redundant, unprofitable routes, and essentially built the highly efficient, centralized backbone of modern American heavy industry. He turned a fractured competitive mess into a streamlined, monopolistic machine.
And the analysis draws a direct, unblinking line from J.P. Morgan consolidating the iron railroads of the 1890s to what Elon Musk and Tesla are doing right now in the 2020s.
It's the same playbook.
They're executing the exact same consolidation playbook for the 21st century. But instead of laying down steel rails and using steam power and coal to force efficiency, the tools of consolidation are artificial intelligence, neural networks, and advanced lithium-ion battery chemistry. They are completely reassembling the fragmented global supply chain, systematically stripping out the inefficiencies of human biological limitations and volatile fossil fuel markets.
It is a fascinating lens through which to view this technological transition. Look at the current diesel trucking industry. It is highly fragmented. You have massive fleets, yes, but you also have hundreds of thousands of independent owner-operators. You have a constant shortage of drivers.
And fluctuating fuel prices.
You have highly unpredictable diesel fuel costs that swing wildly based on geopolitical conflicts. It is the modern equivalent of the 1890s railroad chaos. Tesla is stepping in with a unified, vertically integrated hardware and software solution to replace that chaos with a predictable, automated, standardized network.
But we need to pause here and ask the ultimate so what question for you, the listener. We've spent an hour geeking out over battery chemistry, logistics, spreadsheets, and Gilded Age history. But why should you, the person listening right now on your commute or while doing the dishes, care about the total cost of ownership of a Class 8 truck?
How does this affect your wallet?
Exactly.
The material answers this by detailing a macroeconomic chain reaction. And it all comes back to that initial concept we discussed. Logistics as a hidden tax. We have to think about the fundamental physics of the economy. The economy is essentially just the process of taking atoms out of the ground, assembling them into useful shapes in a factory, and then moving those finished atoms to the people who want to buy them.
Moving atoms is expensive.
Incredibly expensive.
Yeah.
If the cost of moving a physical good from a factory in Mexico to a port in Texas, and from that port to a warehouse in Ohio, and from that warehouse to a retail shelf in your hometown is slashed by 50 or 60%, which is exactly what the economics of the autonomous electric semi promise to do, then the fundamental floor price of every single physical good in the economy drops.
That is a massive statement. We aren't just talking about the price of shipping dropping. We are talking about the price of the actual items dropping.
Everything. A simple cotton t-shirt, a massive flat-screen television, the fresh avocados in your local supermarket, the lumber and drywall required to build new homes, the medical equipment in hospitals.
It's universal.
A highly significant percentage of the cost you pay at the final register is allocated strictly to cover the burned diesel fuel and the human labor required to physically transport that item across the map. If you permanently remove the volatility of diesel fuel costs, and you completely remove the biological human labor bottleneck, the baseline cost to produce and deliver that good plummets.
And that leads to a drop in inflation.
Therefore, the analysis emphasizes that the mass deployment of the Semi is positioned not just as a successful vehicle launch, but as one of the most powerful structural weapons against global inflation in existence today.
That is the big payoff of this entire deep dive. We have spent the last few years terrified of inflation. We have watched prices tick up and up, feeling the pain at the grocery store, largely driven by supply chain shocks and labor shortages. Central banks try to fight inflation by raising interest rates, which hurts regular people trying to buy a house.
It's a blunt instrument.
But what this material is arguing is that the mass deployment of automated electric logistics is a massive technological deflationary force. It forcefully drives prices down, not by manipulating interest rates, but by using software and physics to make the movement of atoms incredibly cheap. It is not temporary economic fix. It is a permanent structural restructuring of how much things cost to move.
And this leads directly to the final global domination strategy outlined in the source text. This technological revolution absolutely does not stop at the borders of the United States. The material points out a very clear, deliberate geographical roadmap. The strategy begins by conquering North America first.
Why start there?
Because the U.S. has the most expansive, highly dispersed, truck-reliant logistics network in the world. It is the perfect, most challenging proving ground. If you can automate the route from LA to NY, you can automate anything. But once the economic model is proven beyond a shadow of a doubt in the U.S., and the manufacturing scales up to hundreds of thousands of units, the blueprint will be rapidly, aggressively exported.
The text specifically mentions Europe and Asia as the immediate next targets. And the logic here is brutal. Once the North American supply chain is completely dominated by this hyper-efficient deflationary technology, the economic pressure on other global regions to adopt it will be overwhelming.
It becomes a matter of basic macroeconomic survival. Imagine a scenario where North America has shifted entirely to cheap, automated 247 electric logistics. The cost to manufacture and ship goods within the U.S. drops dramatically.
Giving them a huge competitive edge.
If Europe, with its incredibly strict emissions targets and high fuel taxes, stubbornly continues to use expensive, human-driven diesel logistics, European goods become instantly uncompetitive on the global market. They will simply be too expensive to buy compared to American goods.
So it's not even about whether European logistics companies want to buy the semi. They will be forced to adopt the technology, or something exactly like it, just to keep their national economies from collapsing under the weight of their own comparative inefficiency.
Exactly. The adoption becomes entirely mandatory for economic survival. And this brings up a crucial paradigm-shifting point for anyone analyzing technology, stock markets, or the broader future of the global economy.
Where should we be looking?
The analysis notes that for the last decade, retail investors, journalists, analysts, has been hyper-focused on passenger vehicles. We look at sleek electric cars parked in suburban driveways and we think, that is the revolution. We are changing the world.
It's visible. It's relatable.
But the material insists that our focus must shift immediately. We need to stop looking at passenger driveways and start looking very, very closely at the commercial highways, the industrial corridors, the ports. That is where the new wealth is being generated.
A heavy infrastructure.
That is where the massive tectonic economic shifts are occurring. The true disruption of the 21st century isn't how you drive to the grocery store. It is how the groceries get to the store in the first place.
It is the silent revolution. It doesn't get the glossy magazine covers, it doesn't get the viral social media trends, but it fundamentally changes the floor price of everything on the planet. Which brings us to our summary and the ultimate listener takeaway. We have covered an immense, heavy amount of ground today, pulling from a dense and highly impactful source text.
We certainly have.
We started by examining the sheer intimidating scale of the Nevada factory, 50,000 units a year of a heavy-duty vehicle that completely rewrites the total cost of ownership math. We broke down the mechanics of a diesel engine, the DPFs, the DEF fluids, the crippling cost of downtime, and contrasted it with the simplicity of the electric drivetrain.
And we debated the miracle crossover.
Yes, exploring how the massive scale of the Gigafactory, combined with the initial boost of green energy subsidies, makes buying a new diesel truck practically a form of corporate malpractice. We then explored the true, terrifying disruptor for legacy industries. 247, full self-driving. We looked at the human toll of the trucking industry and how removing the biological bottleneck, the mandated need for sleep, the hours of service regulations effectively doubles the speed of freight across the continent, and how that hyperspeed alters the velocity of capital, freeing up billions in inventory.
We also saw how legacy automakers are hopelessly trapped in a legacy mindset, trying to do simple powertrain swaps while Tesla builds an insurmountable, vertically integrated moat of proprietary megachargers and billions of miles of advanced AI training data.
And finally, we looked at the massive macro picture, the J.P. Morgan parallel, the idea that by stepping into a fragmented, chaotic industry and drastically lowering the cost of logistics through technological consolidation, this vehicle acts as a structural weapon against global inflation.
The sheer gravity of what we are watching unfold is profound.
We are literally watching the 100-year-old dominant diesel trucking industry be marched quietly into a museum, rapidly replaced by silent, 247-wheeled supercomputers.
It is a transition that will define the economic reality of the next 50 years.
And we want to remind you, the listener, that by taking the time to dive deep into these mechanics, you now have a massive informational edge over the general public. The next time you are sitting in a meeting at work discussing supply chain delays, or you hear someone complaining about the stubbornness of inflation at the grocery store checkout, you understand the underlying structural shift that is currently being built to solve it.
You know exactly what is happening out there in the Nevada desert.
And as we wrap up our analysis of this material, it raises one final, incredibly important question. Wait, no, scratch that. It raises one final, incredibly important question, one that builds directly on the reality the source has outlined today.
This raises an important question. The source details a future where goods move relentlessly, 247, without human limitations, effectively dropping the cost of distance to near zero. If geography and distance no longer dictate the price of our goods, how will that fundamentally change where we choose to live and how our cities are physically built once they are no longer tethered to the slow pace of human-driven supply chains?
That is a profoundly massive thought to chew on. When the cost of distance goes to zero, the physical map of the world and where humanity chooses to settle on it changes entirely. Thank you all so much for joining us for this deep dive. We hope you walk away seeing the highways, the trucks, and the price tags around you a little bit differently today. Keep questioning the world around you. Keep looking past the flashy headlines for those silent revolutions, and we will see you next time. Take care.